So far in the course, we've talked about how to generate web pages using Python and to process forms using CGI scripts written in Python. But real web programmers would never process a form in that way. Instead, what they would do is use a framework. And what is a framework? Well, a framework is a package of already provided Python scripts that does certain tasks for you automatically. So for example, instead of processing a form directly and accessing the CGI field storage class and checking if there's a key and fetching it, we can rely on a framework to fetch the data from the form for us. And frameworks provide lots of different features, and so most websites today are written using frameworks. So what is a framework? Here's the formal definition. It's a software library that provides functions to make web programming easier and more robust. Robust, of course, means that it is less likely to fail. Another way to look at frameworks is that they provide a special kind of web server that's different from a typical web server, and it can be programmed to handle inputs from a web client. So we can send form data to this special web server, and then we can program it to respond in the way that we want. We can customize it. Another way to look at frameworks is that a framework is a community of users who share code for common tasks. So most of the frameworks have a very active community. They have forums that they post on, and they have mailing lists that you can subscribe to get more help or hints about how to do certain kinds of tasks. So a framework could be any of these things. It's sort of all of these things. But primarily, we're going to treat a framework as a software library. So there are some really popular frameworks. One of them you've probably heard of is Ruby on Rails. It's based on the Ruby programming language, and it's a very easy to use web templating language. Another is Node.js. This is becoming very popular. The advantage of Node.js is that it's based on the JavaScript language, which you've already learned. So if you've learned JavaScript so that you can write code in the client and run things in the web browser, now you can use JavaScript on the server as well to process your forms and handle it. And it integrates very nicely with other JavaScript libraries. Node is the base, the foundation of something called the mean stack. There are two really common software stacks that are collections of programs that we use together to produce web applications. And one of them is the mean stack, which stands for MongoDB, a database system, Express.js, and Angular.js. And then they run on top of Node.js, which is the server. So Express and Angular are JavaScript libraries for doing client-side stuff. Encourage you to explore those for use as in the creative section of your next project. But you don't have to use Node.js to use Express and Angular, but a lot of people use those four things together to develop web applications. Another popular framework is called Zend, and it uses the PHP programming language as the back end. It's often used on a LAMP stack. LAMP stands for Linux with Apache, MySQL, and PHP. So MySQL is an alternative database to Mongo, and PHP is a programming language that's often used for web programming. We may learn a little bit of PHP at the end of this course. LAMP stack, WAMP stack. WAMP is the same thing but with Windows instead of Linux. And Zend is commonly used in those environments. But there are also some very popular frameworks based on Python, and some of them are listed here. So Zope, for instance, runs on Python. You may have heard of Zope. I actually have some friends from grad school who work for Zope. Django is another popular Python framework. It's been around a long time and has a pretty established user base. A really neat one that's very, very powerful and has lots of features is called, well, it used to be called Pylons, and now it's called Pyramid. But you won't find it if you Google for Pyramid, because you'll get lots of other things named Pyramid. But if you Google for Pylons, you'll find Pylons Pyramid and be able to find documentation on it. And then there's something called Flask. And we're going to use Flask in this course. I love Flask. I use it for lots of different projects. It's a very, very easy to use framework. It's what's called a micro framework. And the idea behind a micro framework is that instead of providing you with lots of features up front, Flask just provides a few basic features, but it's very modular. There's lots of different things that you can kind of plug into it to add functionality. And so you can pick only the things you need and plug them into Flask. And this has some performance advantages. Flask servers can run really fast. They can respond to lots of users at the same time. If they're getting lots of hits, maybe you have a really popular product and it's Black Friday and everybody's trying to buy, Flask is fairly responsive and can handle a lot of traffic all at once. But also, it means that it's easier to learn and understand because you can start with the basic Flask and then just learn the modules that you need when you need them and pull them into your project. So I think you'll enjoy working in Flask. It's going to automate a lot of the really tedious tasks that we had to do working with just plain CGI scripts. So here's an example of a Flask application. So we would create a program, maybe like server.py would be the name of the file. And the first thing that we do is we import the Flask module. So we say from Flask, import capital Flask. And Flask with a capital F is an object in Python. It's a Python class. And we can create servers using the Flask object. So here I'm going to create a new web server named app. And so I say app gets Flask, and in parentheses, I pass in underscore underscore name underscore underscore. This is a predefined variable. When you run a Python script, Python fills in underscore underscore name underscore underscore with the name of your program. So if the name of this file was server.py, name will be server or server.py. And so we're going to create a web server with that name, and we're going to call it app. So we have a new variable app that we can access to manipulate the server. One of the new features of Python that's been added in the last couple versions is the ability to have what are called decorators. And decorators start with an @ sign, and it turns out that decorators are actually functions, but they behave as if they were special comments. You don't really have to understand the mechanisms of decorators to understand what @ app.route does. Instead, think of it this way. I'm going to have a function which I call main. So notice I have def main : and then it returns a bunch of HTML. This is a function that creates a string representing a web page. And when a user connects to my web server, the web server is going to run this main function, which creates this web page and sends it back to the client, back to the web browser. Somehow, the web server has to know which page they want. And that's what the decorator is for. So the @app.route of slash says that the main page of this application, the slash page, the page they go to if they go to, for example, project.example.org slash, that page is this. They're going to get the doc type HTML, the HTML lang gets en, the head and the title is Flask example, the slash title, the slash head, and then a body that says hello world. So that's what's going to happen. And then at the very bottom, we have some code that you have to put in your Flask applications. You have to say if, and then you have to check if underscore underscore name is equal to underscore underscore main. And if it is, then we're going to run the server. So app.run. So this is great. Oh, by the way, let me go back. One thing I want you to notice, I did not have to put the HTTP headers into my string. When I returned my web page, I just started with doc type HTML. I didn't have to put content type text HTML in there. That's because Flask is going to do it for me. So it's already automating some of the tasks that I would have had to do if I did this by hand with a CGI script. So by default, Flask runs on the local system only. It's only accessible if you're on the server. And it uses port 5000. The reason for that is that this is a good setup for testing. If I'm testing a web page, I want to be able to access it, but I don't want other people to log into it yet because I'm not done, it's not production ready. So this isn't going to work if we're all on the same system trying to use the same port. If we all try to use port 5000, when whoever logs in first will run their server, and it'll be sitting there on port 5000, and when another student logs in and tries to run their server, it's going to see that port 5000 is busy, and this isn't going to work. So you need to tell your Flask program to use a different port number. And so what I've done is I've set up the computer science server so that it will forward connections to, from your Lab 5 folder, for example, to a Flask server running on a certain port number. And I've given each of you a unique port number that you can use for your Flask program. So when you create a Flask program for your next lab, your app.run function will specify a host address of 0.0.0.0 that says to listen both on the server and to the outside world so that incoming connections will be allowed. And then you say port equals and your port number. So here, for example, I have 5001. So the way that I'm going to do this, you have an account on Gandalf. Maybe you are student 3 or student 8 or student 9 or student 7. Take the number at the end of your login name and add it to 5000. So if you're student 0, port 5000 is your port. If you're student 1, port 5001 is your port. If you are student 32, port 5032 is your port. And put that in your code, and then your server will run. And when you go to gandalf.cs.longwood.edu/twiddle your username /lab5 or lab6, whatever lab number it is, it will be forwarded to the appropriate port. It'll be lab 6. It'll be forwarded to the appropriate port so that you can see your Flask application. So what's the advantage of doing this? Why would we want to use a framework instead of just printing web pages? Well, one advantage is that I can create a Python function that automates some of the tasks we have to do for every page. For example, every single web page that I produce is going to have a header and it's going to have a footer. That header is going to have the doc type tag and the HTML tag and the head and title tags. And the footer is going to have my /body and /HTML tags. So I'm going to have to put those in every single web page. It seems kind of silly to type them over and over and over again. If I use a framework, I can create a function that does that, and then I can just call my function and allow Flask to trigger it appropriately. Now, for the header, I might want to have pages with different titles. So I'm going to make the title an argument, a parameter to the function. So I will say header, and in parentheses, I'll put a string representing the title. Maybe it's example page, or maybe it's order form. And the function will fill that information in. So here's an example header function. I'm going to define a function. The name is header. It takes one parameter, the title. Notice I have a colon at the end, because that's how Python does functions. And then I indent. And I'm going to just return a string. And the string contains the doc type tag, the HTML tag, the head and title tags. And then I stop that string and put in the title from the variable. And then I put my /title tag, my /head tag, and I open up my body tag. My footer function is even simpler. I'm just going to return a /body tag and a /HTML tag. So now I can use my header and my footer to produce web pages. So here's how I could do that in a Flask application. I'm going to say from Flask, import Flask. I'm going to say app gets Flask and put my __name __ in. And now I'm going to use my decorators, my app.route, to tell it if you go to just the main page, print a website. But if you go to /page2, so gandalf.cs.longwood.edu/page2, for example, then print a different page. So the first page I'm defining in a function named main. And I'm going to use my header function with the title Flask example to produce the doc type tag and all that information that goes to the beginning of the web page. Then I'm going to print a string that contains a paragraph saying hello world. And then I'm going to add my footer to the end. Notice how much easier this is than the example I did before I defined these functions. Here, I had to put the entire web page into one string. But now, I can just call my header function and say Flask example for the title. I can add my hello world paragraph to it and then tack on my footer at the end. And now I can use my app decorator to add a new route that says if they go to this other page, to page 2, instead of running the main function, run this page 2 function that I've defined. And in the page 2 function, I can return a header with the title page 2. I can put in a different paragraph that says this is page 2 of the website. And I can say go back and make go back a link to my root page. And then I tack the footer on the end. And again, at the bottom, I have to say if name is main, then run the web server. This is because Flask might get triggered from a different web server like Apache. You can actually embed a Flask program into Apache and run it as a module. If you do that, though, it's going to play some interesting games. And for it to interface correctly, you have to make sure that it's actually being run. It's not just being examined by Apache to see what kind of script it is, for example. If you don't understand that, it's not important. It's just details of the mechanism. But you always need this if name == main at the bottom of your code to be safe. So let's talk a little bit more about routing. How does Flask know which function to call when the user requests a particular page? So it turns out that you can actually create multiple similar pages using a single function. And the way that you do that is you put these placeholders in your URL. And placeholders can be identified because they will have angle brackets around them. You can't actually have a less than or a greater than in a URL. Those are not legal characters in a URL. So Flask will use those as sort of placeholders that identify some sort of text or variable. So for example, here I have @app.root, and I have, in quotes, /product/ and in angle brackets I have a product ID. So if the user went to gandalf.cs.longwood.edu /product/3, then what will happen is that Gandalf will remember that 3 is the product ID. But if they go to /product/7, then it'll remember that 7 is the product ID. And no matter what number they type in for the product ID, it's going to call the display product function. But notice now it's going to pass in a parameter. It's going to set the variable ID to be the product ID. So if we go to /product/3, it's going to set ID to be 3. If we set /product/7, if we go to that URL, it's going to put 7 in the ID variable. So for example, I could print product : and then a 3 or a 7 by doing +ID. And then I could print the price is, and I could multiply the ID by 20 to calculate the price. Maybe product with the ID, product 3 is $60 and product 7 is $140. Probably your pricing system is very different from this, but it's an example. Notice that I have to cast the ID to an integer to be able to multiply it. By default, Flask treats all of these placeholders, all these variables, as strings. So you have to actually cast it to an int to be able to treat it like a number. So if I go to http:// whatever my server is, example.org /product/2, that's going to print out product 2, price $40. If I go to http:// whatever my server is, /product/3, then it's going to print out product 3, price $60. You can also limit a route to just one method. So maybe I have a function that processes a form, and I don't want that function to run if they didn't get there by posting it from a form. So I could say @app.root, and in parentheses I could say, in quote marks, /processForm, quote marks. So if they go to server : or http:// server name /processForm, it's going to call this function, but only if the method was post. If the method isn't post, then it's going to give an error message. But if they submit a form to process form, then it'll call the handle form function, which will print a web page saying nice form. You can also, instead of specifying one method, you can specify a list of methods. So you can, for example, restrict it to just get and post requests. So I can say @app.root /example methods equals, and then the list post, get. And so if it's either a get request or a post request, it'll trigger this function named example, and it'll print you used get or post instead of something like head or put. Another feature of Flask is the URL_for function. So if you import the URL_for module, so up where we say from Flask import Flask, we have to tack on comma URL_for. Then you can easily create links to the other functions in your application. So I can say @app.root / and I can have a function named index that I define that just prints the words main page. But I can then define a new route @app.root / about.html that will trigger the about function. And the about function will print the words, this is an example about page, and then it will print a link with ahref, but it's going to set the URL of that link to be the URL associated with the index function. So the URL associated with the index function is the /URL, the root page, and so it'll actually insert a / for you here. We're going to use that a lot. Another useful module is the request module. So from Flask import Flask, and maybe also URL_for, and then request. And this is how we fetch form data. So if I say @app.root, and I'm mapping the process form URL to this function, my process form function, and I'm going to set my methods to be either get or post, I can actually use the request module to determine whether it was a get request or a post request. So I can say if the request method was get, and I just say request.method = get, then I'm going to return some HTML code for the form. Actually, I would probably use my header function to print out the doc type tag and everything, and then I would print the form and then my footer. but it didn't all fit on the slide nicely. So here I'm just printing out the HTML for the form. My action is /process_form, and my method is post. If I were going to upload a file or something, I might add my enctype attribute. I've got two inputs. They're both text fields. One is for a first name, one's for a last name, and then I have, of course, my submit button. If it was a post request, I'm going to trigger the process form URL. But my if statement will catch that, and instead of printing out the form again, it's going to fetch data from the form. So it's going to fetch the first name field and the last name field, and it's going to put the first name into a variable named first and the last name into a variable named last. And then it's going to return a string that says your name is first plus a space plus last. So if you type in your first and last name and hit enter, it'll know that, and it'll fetch those from the form and print out what they are. We can actually also use request to access cookies. So if we want to do that, we need the make response function. So from Flask, import Flask, URL for, request, make response. We're going to pull that into. Again, I have my decorator at app.root, process form. My methods are get and post. I'm actually missing a parenthesis, so let's put that in really quickly. It should be there. There should be a parenthesis here and a colon. Look at that. There it is. So I'm going to, oh, no, there shouldn't be. There should just be a parenthesis there. The colon goes with the function. So we can also use request to access cookies from Flask, import Flask, URL for, request, make response. And now my decorator is correct at app.root. And in parentheses, I say process form is the URL associated with this function using either the methods get or post. My process form function now says if the request method was get, instead of just printing the form out, I'm going to add a line that says check for any cookies and see if they have a last name field. So I'm going to get any cookie associated with the key value last. And then if so, I'll print out your name is and the last name, and then print my form. On the other hand, if they're submitting the form, then they used a post request. And so I'll fetch the first name and fetch the last name just like I did before. But now I'm going to use make response to actually change the HTTP headers. And I want my response to be your name is first plus last. But I'm also going to set a cookie in the response. I'm going to set a cookie named last to be the last name. And then instead of returning a string, I'll return the response that I created. So instead of returning a string, I'm returning a response object that contains both the HTTP headers and the HTML. And those HTTP headers will include the set cookie header. Notice how much easier this is than doing cookies with the CGI stuff. So these are some of the features of Flask, but the real power of Flask is that it can be used with another web framework library called Jinja. And Jinja is a web templating library that will allow us to create web pages using HTML, but then actually embed Python code directly into them. So if I want to repeat something a bunch of times, I can put a for loop right into the HTML of my web page, and Jinja will take that template page and generate real HTML pages from it that do all the work for us. It'll interpret the for loop. We're going to learn a lot more about that in the next lecture. Have a good week.